Okay, class, this next lesson is devoted to the double angle and half angle formulas, and we can see that a sine of 2 theta is called a double angle because it's twice some angle theta, but we could also write this as the sine of theta plus theta. So there's my 2 theta. And we've already developed a rule for the sum and difference formulas. Remember we said that the sum for sine of some alpha plus beta is equal to the sine alpha times the cosine of beta plus the cosine of alpha times the sine of beta. Okay, so let's just use that to derive the double angle formula, what happens when I take a sine of alpha plus alpha. So just plugging alpha in for both, just plugging theta in for both alpha and beta, we're going to get a sine theta times a cosine theta plus a cosine theta times a sine theta. Okay, so really these are the same two terms because we can commute the multiplication. So we can reduce this to 2 instances or 2 times, and we'll start with sine. Okay, so this is what happens to a double angle sine. Let's take a look at cosine. Again, we'll write it as theta plus theta. And if you look back at your addition rule, or some rule for cosine, the cosine is going to be, if it's alpha plus beta, it would be cosine alpha cosine beta. So since both alpha and beta are theta, we can write that as cosine theta cosine theta. And remember, in the sum for the cosine, we actually subtract there, and then it's sine Okay, so we can see that we're squaring a cosine, and then we subtract and we're squaring a sine. So we can see the double angle formula for the cosine is going to be cosine squared theta minus sine squared theta. Okay, so just insert this over here. This was cosine 2 theta. Okay, so we've got both of these established just using the sum formula that we learned previously. Okay, so we want to take a look at some application of our new formulas here. I do want to say first, though, that there's actually more than one way to look at the cosine of 2 theta. So this is the one that we showed in the last example. But if we remember that the sine squared theta plus the cosine squared theta equals 1. Okay, that was our Pythagorean. So if you substitute and solve for either cosine squared theta or sine squared theta, we can produce these two other forms of cosine 2 theta. So those might come in as a handy way to represent cosine of 2 theta. Okay. All right, so our goal here is to find if the sine of theta equals 3/5. We want to know what thetas belong between pi over 2 and pi. So we're talking about something in this second quadrant. Here's pi over 2, here's pi. So we're looking for an angle in that range, and for a sine of 2 theta, if we know the sine of theta is 3/5. So the sine of theta is 3/5, and anytime they give us the sine, they also give us the cosine, because we can always pop that into the Pythagorean identity that we just discussed and looked at. Okay, so I'm going to take the sine of theta, and we may need some other information, but they give that to us. So we'll see what, because it's in this quadrant, we know that the cosine is negative. Okay, so the 3/5 squared plus the cosine squared theta equals 1. So this is 9/25. All right, and I'm just going to subtract 9/25 from both sides. So I know that the cosine squared of theta is equal to 16/25. If I take and subtract 9/25 from 1, I get 16/25. So finally, our square root property tells us that the cosine of theta is equal to plus or minus the square root of 16/25. So that's plus or minus 4/5. And since they told us we're interested in a theta between pi over 2 and pi, it puts us in quadrant 2 where the cosine or the x coordinate is always negative. So we're going to throw away the positive and just take negative 4/5 for cosine of theta. Okay, so now for part A, we want the sine of 2 theta. And we've got both the cosine and the sine now, so we can plug it into our formula. And the cosine of 2 theta is going to be 2 times the sine of theta, which they gave us to be 3/5. And then times the cosine of theta, which we calculated had to be negative 4/5. Okay, so if we multiply all that together, we're going to get 24/5, and it'll be negative. I'm sorry, negative 24 over 25. Okay, and we can't reduce that. Okay, let's look at this next one here. We have cosine of 2 theta. And I've got several options to choose from. We can use the one we derived originally or the other ones that apply because of substitutions from Pythagorean identity. I'm just going to use the first one that we derived. So I'm going to take the cosine of theta, which we know now to be negative 4/5. So I'm going to take negative 4/5 squared minus sine squared theta, so 3/5 squared. Okay, and that's going to give me positive 16/25 minus 9/25. Okay, so that's going to result in 7/25. Okay, now we're going to do a similar thing with the tangent, and we're going to say, what would a tangent double angle look like? And we can do that because we also saw in the last lesson that the tangent of alpha plus beta is equal to this. So we'll use that and develop a double angle formula for tangent. So the tangent of 2 theta is like the tangent of theta plus theta. And we'll just plug it into our formula here. So theta is substituting for both alpha and beta here, so everything's theta. Okay, so we'll just simplify that result. There's 2 tangents of theta above 1 minus tangent squared theta. Okay, let's say we want to come up with the triple angle formula for sine. We'll just split that up into oops, no more tangent. We'll just split that up into a sine of 2 theta, which we've already figured, plus theta. And again, we'll just plug that into the sum formula for sine. So I'm going to take sine of the first one times the cosine of the second plus cosine of the first times sine of the second. Okay, so at this point, we're going to just go ahead and substitute what we know to be sine of 2 theta and cosine of 2 theta. Okay, so substituting for sine of 2 theta, we're going to get 2 sine theta cosine theta. And then we also have this factor of cosine theta still there. So the cosine of 2 theta we're going to write as cosine squared theta minus sine squared theta. And then it's times sine of theta over here. Okay, so cleaning this up a little bit, we would end up with 2 sine theta cosine squared theta plus sine theta cosine squared theta minus sine cubed theta. Okay, so this can come together with this. These are like terms. So there's 3 of them total. 3 sine theta cosine squared theta minus sine cubed theta.